The countdown to Betelgeuse's supernova may have already begun. This massive star, located in the Orion constellation, has been one of the most studied stars in the sky. Recent observations have given astronomers a glimpse into its unstable future. Betelgeuse, a red supergiant, has been fluctuating in brightness, with periodic dimming and changes in its appearance that suggest it is nearing the end of its life. Scientists have been closely monitoring these fluctuations, and while the exact timing of its eventual explosion remains uncertain, some believe we might be closer than ever to witnessing this dramatic event. Some even think it could occur within our lifetime, an event that would provide groundbreaking insights into the death of massive stars. What makes Betelgeuse even more fascinating is the ongoing mystery surrounding its behavior. For years, astronomers believed that Betelgeuse, like most massive stars, was a solitary star slowly dying. It had been a typical red supergiant star, burning through its hydrogen and helium fuel and slowly swelling to an enormous size. But recent findings have upended that assumption. There's evidence that Betelgeuse might not be a solitary star after all. In fact, it could be part of a binary system, with a companion star influencing its behavior in unexpected ways. Some of Betelgeuse's more unusual characteristics, such as its erratic dimming and rapid rotation, have led some astronomers to suggest that the companion star could have played a crucial role in accelerating Betelgeuse's aging process, possibly contributing to the unusual fluctuations we are seeing. Using powerful telescopes like ALMA, Atacama Large Millimeter/Submillimeter Array, astronomers have found evidence of what is called stellar cannibalism. This occurs when a star absorbs material from a companion star, drawing mass from its partner. This interaction could explain Betelgeuse's erratic behavior and rapid rotation. As Betelgeuse cannibalizes its companion, the material it absorbs could affect its internal processes and lead to the observed dimming and fluctuations in brightness. Some researchers suggest that this could be a precursor to the star's impending collapse, as the sudden influx of material could destabilize Betelgeuse, pushing it closer to a supernova. A supernova is one of the most violent events in the universe. When a massive star dies, it undergoes a rapid collapse, creating an explosion so powerful that it releases a burst of energy visible across vast distances. In the case of Betelgeuse, when it eventually explodes, the amount of energy released would be immense, scattering elements like iron, carbon, and oxygen into the surrounding space. These elements are vital for the formation of new stars, planets, and even life itself. Without supernovae, these building blocks of life would not be created, and the universe would look very different. The explosion of a supernova not only marks the end of a star's life, but also contributes to the ongoing process of cosmic evolution. The elements dispersed during a supernova explosion are recycled into the next generation of stars and planets, making supernovae crucial for the ongoing development of the cosmos. Supernovae are not just spectacular events. They serve as important tools for understanding the universe. By studying the remnants of a supernova, scientists can track the conditions of the star before it exploded, providing valuable insights into the evolution of galaxies and stellar populations. Supernovae are also used to measure the size and age of galaxies, helping astronomers better understand the history of the universe itself. They allow us to glimpse the future of stars, including our own sun, and predict when other stars might go supernova. However, predicting when Betelgeuse will go supernova remains a challenge. The star's fluctuations in brightness are not fully understood, and the recent discoveries surrounding its companion star and the surrounding cosmic environment add even more complexity to the situation. One of the key unknowns is the role of the gas clouds that have been found around Betelgeuse. These clouds could be affecting the star's behavior, but it's unclear whether they are part of a temporary phenomenon or if they represent a more permanent change in the star's structure. In addition, Betelgeuse resides within a hot bubble in space, a dynamic and active region that could be influencing the star's life cycle in ways that we don't yet fully understand. Could the hot bubble be accelerating Betelgeuse's death? Or is it simply a part of the normal process of stellar evolution? These questions remain unanswered, and each new observation only adds to the mystery. This uncertainty is one of the biggest challenges in studying Betelgeuse. With so many variables at play, the companion star, the gas clouds, and the hot bubble, astronomers can only speculate about when Betelgeuse will explode. Predicting the supernova's exact timing is nearly impossible, and the unpredictability of the star's behavior has pushed scientists to develop new technologies to monitor it. The challenge of observing Betelgeuse from Earth is further compounded by its immense distance, around 640 light-years away, making it difficult to study with the precision that astronomers would like. Despite these challenges, the potential breakthroughs that could come from studying Betelgeuse are significant. As researchers continue to refine their observation techniques, they may unlock new insights into the behavior of dying stars and the processes that lead to supernovae. For example, developing more advanced space telescopes that can capture detailed images and data from distant stars will enable astronomers to monitor Betelgeuse and other similar stars more accurately. These tools could open up new possibilities for understanding the evolution of massive stars, and they may even improve our ability to predict when other stars are nearing the end of their life cycle. The mystery surrounding Betelgeuse is not just about predicting when it will go supernova. It's about the fundamental questions it raises about the life cycles of stars. How do stars like Betelgeuse evolve, and what causes their sudden collapse? Could Betelgeuse's supernova reveal new phenomena that challenge our understanding of stellar evolution? As the research continues, new discoveries are being made, but these discoveries also raise new questions. For example, if Betelgeuse's supernova is imminent, what could it tell us about other massive stars that are even farther away? What could the radiation and shock waves from Betelgeuse's explosion teach us about the effects of supernovae on nearby star systems, including our own? If Betelgeuse were to explode sooner than expected, the effects would be spectacular. While the explosion wouldn't directly affect Earth, it would likely be visible in the sky, perhaps even during the day. The radiation released could potentially affect satellite communications and GPS systems as cosmic rays would interact with the Earth's atmosphere. While the explosion itself would not pose a direct threat to life on Earth, it would provide astronomers with an unprecedented opportunity to study a supernova in real time. The data gathered could provide critical insights into how stars die, how elements are created, and how the process of star formation continues across the universe. So what happens if Betelgeuse explodes unexpectedly? How will it change our understanding of the universe? And could it lead to discoveries that reshape our theories of stellar life cycles? With each new discovery, we get closer to understanding the fate of this enigmatic star and the cosmic mystery that lies beyond it. The next few years could bring answers that change everything we thought we knew about stars, their deaths, and the forces that shape our universe. Will Betelgeuse surprise us before we expect it? Only time will tell. But one thing is certain. When Betelgeuse finally does go supernova, it will be a defining moment in the study of astrophysics. As astronomers continue their research, we may see the development of new technologies that could allow us to monitor Betelgeuse more closely, potentially leading to even more groundbreaking discoveries. Whether Betelgeuse explodes in our lifetime or remains a distant burning mystery, its eventual supernova promises to be a major event in our understanding of the cosmos. Keep watching as we explore the countdown to Betelgeuse's explosive death, and stay tuned for more updates on the mysteries of the universe that continue to unfold before us. Betelgeuse is an extraordinary example of a massive star nearing the end of its life cycle, offering astronomers a rare opportunity to study the processes that occur just before a star explodes as a supernova. To understand why Betelgeuse's supernova is so important, we first need to examine how stars like it evolve and eventually die. Stars are born from clouds of gas and dust in space. When a star forms, it begins by fusing hydrogen atoms into helium in its core, a process that releases a tremendous amount of energy and provides the outward pressure that keeps the star from collapsing under its own gravity. This fusion process is what powers the star and causes it to shine brightly. As a star ages, it exhausts its hydrogen supply and begins to fuse heavier elements like helium, carbon, and oxygen. This results in the star expanding and becoming a red giant, or in the case of very massive stars like Betelgeuse, a red supergiant. Betelgeuse is already in this phase, and it has been for millions of years. However, stars like Betelgeuse eventually run out of the fuel needed to sustain fusion reactions in their cores. When this happens, the core begins to collapse, and the outer layers of the star are expelled into space. The end result is a spectacular explosion called a supernova. The timing of a supernova is influenced by a variety of factors, including the star's mass, composition, and the nature of its environment. The fate of Betelgeuse has intrigued astronomers for years because it is one of the most massive and closest stars to Earth that is likely to explode as a supernova in the near future. It is a living example of the cosmic processes that govern the life and death of stars. One key aspect of Betelgeuse that sets it apart from other massive stars is the possibility that it is part of a binary star system. While Betelgeuse has long been considered a solitary star, recent research has suggested that it may actually have a companion star. This companion star could be influencing Betelgeuse's behavior in ways that are not fully understood. For example, the companion might be siphoning material from Betelgeuse, a process known as stellar cannibalism. This transfer of mass could be accelerating the star's aging process and causing some of the unusual fluctuations in brightness that have been observed. In many cases, stars in binary systems interact in complex ways, with one star potentially draining material from the other. This process can lead to a variety of outcomes, including the formation of a neutron star or even the creation of a black hole if enough mass is transferred. For Betelgeuse, the presence of a companion could explain some of its unusual characteristics, such as its rapid rotation and the periodic dimming events that have mystified astronomers. The companion star could also be a key factor in determining the timing of Betelgeuse's supernova. If the companion is adding material to the supergiant, it could be accelerating the star's core collapse, leading to a supernova sooner than expected. While Betelgeuse is located about 640 light-years away from Earth, its eventual explosion as a supernova will still have a profound impact on our planet, albeit in indirect ways. Supernovae release enormous amounts of radiation and energetic particles, including cosmic rays, which can have a variety of effects on Earth's atmosphere. One of the potential consequences of a nearby supernova is the depletion of the Earth's ozone layer. This could allow more harmful ultraviolet radiation from the sun to reach the surface, potentially affecting ecosystems and increasing the risk of skin cancer in humans. Fortunately, Betelgeuse is far enough away that its explosion would not pose a direct threat to life on Earth, but it could still cause some disruptions to communication systems, satellites, and even the Earth's climate. The light from a Betelgeuse supernova would also be visible to the naked eye, and it could even be bright enough to be seen during the day. Such an event would undoubtedly be a spectacular sight, and it would provide astronomers with an unprecedented opportunity to study the final moments of a massive star's life. Supernovae are rare and fleeting events, so the chance to witness one up close is an exciting prospect for scientists and stargazers alike. Supernovae are not only spectacular displays of cosmic violence, they also play a crucial role in the formation of elements that are essential for life as we know it. When a star explodes in a supernova, it scatters heavy elements like iron, carbon, and oxygen into the surrounding space. These elements are the building blocks of planets, stars, and even life itself. In fact, many of the elements that make up our bodies, such as carbon, nitrogen, and oxygen, were originally formed in the cores of stars that exploded as supernovae billions of years ago. The explosion of a supernova is so powerful that it can create elements heavier than iron, which are then dispersed into the interstellar medium. Over time, these elements become incorporated into new stars, planets, and even life forms. Without supernovae, the universe would be a very different place, as the heavy elements needed for the formation of planets like Earth would not exist. Supernovae are, in essence, the cosmic factories where the raw materials for the universe are created and distributed. As Betelgeuse continues its journey towards supernova, it is becoming a key object of study for astronomers interested in understanding the final stages of a massive star's life. The unprecedented opportunity to observe Betelgeuse as it nears its explosive end could lead to a wealth of new information about stellar evolution and the death of stars. However, this opportunity also comes with challenges. Betelgeuse's behavior is unpredictable, and its fluctuations in brightness make it difficult for astronomers to pinpoint exactly when it will explode. To overcome these challenges, astronomers are using advanced techniques and technologies to monitor Betelgeuse. One of the most important tools is the use of large ground-based telescopes, such as the Very Large Telescope, VLT, in Chile, and space-based observatories like the Hubble Space Telescope. These instruments allow scientists to capture high-resolution images and spectroscopic data that can provide insights into the star's internal structure and its surrounding environment. In addition, astronomers are developing new technologies that will enable them to observe Betelgeuse and other massive stars with even greater precision. For example, the upcoming James Webb Space Telescope, JWST, set to launch soon, will be able to observe stars like Betelgeuse in infrared wavelengths, revealing more details about their internal processes and the materials around them. The combination of these cutting-edge tools and the wealth of data being gathered from multiple observatories will likely lead to significant advances in our understanding of stellar life cycles. In many ways, Betelgeuse is like a laboratory for studying the processes that govern the birth and death of stars. Its massive size, proximity, and ongoing fluctuations make it an ideal candidate for studying the life cycle of a red supergiant and the factors that influence its eventual explosion. As scientists continue to study Betelgeuse, they are learning more about the physics of stellar interiors, the dynamics of stellar atmospheres, and the interactions between stars in binary systems. The research conducted on Betelgeuse may also have broader implications for our understanding of the universe as a whole. By studying the life cycles of stars like Betelgeuse, astronomers can gain valuable insights into the formation and evolution of galaxies, the distribution of elements in the cosmos, and the processes that lead to the formation of planetary systems. Understanding how stars like Betelgeuse evolve and die will help us answer fundamental questions about the origins of our own solar system and the conditions that make life possible on Earth. Betelgeuse's impending supernova remains one of the most exciting and mysterious events in the field of astrophysics. While the exact timing of the explosion is uncertain, the ongoing research into this enigmatic star is providing new insights into the life and death of massive stars. Whether Betelgeuse explodes in the next few years or continues to surprise us with unexpected behavior, it will undoubtedly remain a focal point for astronomers as they seek to unlock the secrets of stellar evolution. The study of Betelgeuse is not only about observing the end of one star's life. It is about understanding the fundamental processes that shape the universe. As we continue to monitor Betelgeuse and other massive stars, we will gain a deeper understanding of the forces that drive the cosmos and the incredible power of supernovae to shape the future of the universe. The countdown to Betelgeuse's supernova has already begun, and the discoveries it holds will likely have far-reaching implications for our understanding of the stars and the very nature of the cosmos.